Okay, chapter 4. We are in designing studies, sampling basics, and bias sampling. So let's start with some basic vocabulary. The population in a statistical study is the entire group of individuals we want information about. The sample is a subset of the individuals in the population for which we want to actually collect the data. Samples should be a small but good representation of the population, a mini version. So you want the sample to resemble what is actually happening in the population. You don't want them to be different. You want them to be very similar. So that's why we have to pay attention to how we collect our sample and who is in our sample compared to the population. A census collects data from every individual in the population. So it's ideal, but not convenient or always possible. So think about the US Census. They collect it every 10 years, but even the US Census does not collect data from everyone that is in the United States. They still miss some people because it's very impossible to get everyone. So we need to identify the population and sample of each of the following. So example 1. The student government at a high school surveys 100 students to get their opinions about a change to the bell schedule. So let's find the population. Population is the entire high school student body. And the sample is the 100 students surveyed. So you take 100 students out of the entire population. B, the quality control manager at a bottling company selects 10 cans from the production line every hour to see whether the volume of the soda is within acceptable limits. So population is all cans produced in a given hour. And the sample is 10 cans selected in the same hour. So they come from the same hour, but population is all of the cans, and the sample is only 10. So types of sampling. We want a good random sample. So our first type is the simple random sample. So you'll see it abbreviated as SRS. We saw it in chapter 1, but we didn't really know what SRS was. Well, now we're learning. So a simple random sample, size n is chosen in such a way that every group of n individuals in the population has an equal chance to be selected as the sample. So you don't want one individual to have more of a chance than someone else. So equal chance is the main takeaway there. So underline equal chance. Okay, so our example. Say a high school has a population with 200 female students and 300 male students. If they number the students and use a number generator, sample 20 females and 30 males for a survey, does this constitute an SRS? Okay, so looks like they're taking 10% of the females and 10% of the males. So it is a no. Each person has a 1 in 10 chance of being selected, but not every group of 50 has an equal chance. For SRS, it should be possible to sample 50 girls, for example. We'll go back there if you need to pause it. Okay, types of good random sampling again. This is a stratified random sample. So you start by classifying the population into groups of similar individual called strata. Then choose a separate, simple random sample in each stratum and combine these SRSs to form a sample. Lots of vocabulary in there, but we're going to do an example so you'll understand a little better. So let's look at this football stadium. So here is the football field, and then here's the stadium. This looks familiar, right? So we want to see what the average price of a ticket for this game is. Describe how you will take a stratified random sample. So you would need to come up with grouping. So our strata is our groups of similar individuals. So in this one, we're going to do each of the 4 levels of seating because each level will have similar prices. So this is level 1. Are there 4 levels? 1, 2, 3, 4. So that's our 4 levels. There we go. Different colors to represent the levels. And so you would take a simple random sample of 50 people for each level, combined for a total of 200 seats per section. And that gives us the sum from all the sections. So that is the key word with stratified random samples. You get sum from all the sections. So that way it will be representative of all the sections. So that's one way to do a random sample. Okay, so that's stratified. Okay, the next one is cluster sample. So you start by classifying the population into groups of individuals that are located near each other, called clusters. Then choose an SRS of a simple random sample of all the clusters. All the individuals in the chosen cluster are included in the sample. So for this, our clusters would be our sections. So we're doing the same football stadium, but this time we're going to do clusters. So number your clusters. We're going to have 12 sections by location. Each section is a mini population. So we have 12 sections. We'll take a simple random sample of the 12 sections and select one, and then we will sample everyone from that one section. So the keyword here is all from one. So see, all from one. For the stratified, it was sum from all. So cluster, you cluster them, you take a cluster, and you sample everyone in that cluster. Stratified, you'll do sum from all the sections. Okay, a systematic sample is another type. You use a random number generator to choose a starting number. Now add in to each previous number to find the individuals to make up this sample. So, for example, you have 200 movies. If you want to sample 10 movies, so you do a random number generator to start. So let's say we just do random number generator to get a starting number from 1 to 20. Let's say 16 was chosen. Then you would do every 10 after that, or 20, sorry. So 16, 36, 56, and so on. And that would get you a random sample. But the problem with this is it's borderline convenience because it doesn't guarantee a representative sample from the population. And that's it.